of 2's and a third set of 2's. If you have more than one set, you can multiply these numbers together. 2 times 2 would be 4, times 2 would be 8 for the number outside the radical. Inside the radical would be a number that we did not circle. In this case, that number would be 5. And all the other numbers we factored down, so we won't use those. So we'd have 8 radical 5. Keep in mind our beginning number, we had a 5 out front. Bringing that 5 over would be 5 times 8. Our final answer would be 40 radical 5. Next question we'll solve is radical 10 times radical 40. When you have two radicals, you can multiply those together. 10 times 40 would be 400, and you can put it under one radical. From there you can do the factor tree. We can use the same two numbers at the beginning, 10 times 40, and factor from there. 10 would be 5 times 2. 40 would be 4 times 10. 4 would be 2 and 2. 10 would be 5 and 2. Again, circle any pairs of numbers. We have a pair of 2's. We have another pair of 2's. And we also have a pair of 5's across the factor tree. Again, anytime you circle more than one number, you can multiply those together. 5 times 2 would be 10, times 2 more would be 20. Looking at the factor tree, there's no other numbers that we did not circle and no numbers that we did not factor. So there's no numbers inside the radical sign. In this case, our final answer would be 20. And that's because 20 times 20 is 400. Last problem for the section is radical 3x times radical 51 x to the third power. Same steps as before. If we have two radicals, we can multiply the numbers. 51 times 3 would be 153. X times x to the third power, that would be 4x's or x to the fourth. And again, this would stay underneath the radical. We'll factor the number first, 153. And again, that number is 3 times 51. 51, there's actually two numbers that multiply to get 51. And those numbers would be 3 times 17. 17 is a prime number we cannot factor. Again, we have a pair of 3's, we can circle those. So the first part of our answer would be 3, and we have a 17 inside the radical sign. For the variables, in this case we have x to the fourth. What we can do is we can write down 4x's. That would be the same as x to the fourth. And the same steps as before where we circle the pairs. In this case we'll circle pairs of x's. We circle two sets of x's, which means the square root of that would be x squared. Putting our number and x variable together, we would have 3x squared times radical 17. First section of notes today is titled Simplify. More radicals. First problem is a radical sign with a fraction 21 over 49. When you take a radical or square root of a fraction, you can break that up for a radical of the numerator and a radical of the denominator. Radical 21, if you try and factor 21, that would be 7 times 3, but there's no pairs and no other factoring. So radical 21 would stay the same. And the radical or square root of 49 would be 7. Our final answer would be radical 21 over 7. The 21 and 7 you cannot divide because one's inside the radical and one's outside the radical. Next question is radical 360 divided by 121. And again, you can take the radical of the top number and also a radical of the denominator. In this case, 360 we can factor. When a number ends in 0 again, that would be 10 times the number. In this case, 10 times 36. 36 would be 6 times 6. One shortcut, we could factor these 6's here, or again, we can circle them because we're looking for pairs of numbers. The 10 we can factor, 2, 5, and 2. In this case, we'd have a 6 outside the radical. There's a 5 and a 2 left. Multiplying those, we'd have a 10 inside the radical. And the square root of 121 would be 11. So our final answer would be 6 radical 10 divided by 11. Last problem for the section. Radical 5 divided by 9a to the 4th. And again, we can split this up with the radical of the numerator and a radical of the denominator. Radical 5 again would stay the same. That cannot be factored or simplified. The square root of 9 would be 3. And for the variables, a to the 4th, again, you can write down 4 a's, circle the pairs. There's 2 sets of a's, which would be a squared. So our final answer would be radical 5 divided by 3a squared. Last section of notes for this section is rationalizing. The denominator. First question for this section is 3 divided by radical 2. For fractions, it's okay to have a radical in the numerator, but if there's a radical in the denominator, we can rationalize it or simplify it. In this case, what we're going to do is if we have radical 2, we will multiply by the same radical for the denominator and also multiply the numerator by that same number. The numerator is 3 times the radical 2. Again, a number and a radical, you cannot multiply together, you just write them side by side. For the denominator, they're both radicals, so you can multiply both of those. 2 times 2 would be radical 4. Simplifying, the numerator would stay the same, and the denominator, square root of 4, would be 2. So our final answer would be 3 radical 2 divided by 2. Again, it's okay to have a radical in the numerator, you just can't have it in the denominator. And these 2's again do not cancel because one's inside a radical and one is not. Last question for this section. Radical 3 divided by radical 7x. Again, for this question, you'll multiply whatever radical's in the denominator, multiply by that same radical for the numerator and denominator. In this case, it's radical 7x. The numerator are both radicals or square roots, so you can cancel those or multiply those together. 7 times 3 would be 21, and the x would be left over. For the denominator, again, they're both in radical form, so 7 times 7 would be 49, and x times x would be x squared. Simplifying, you can try and do a factor tree on 21. The only two numbers are 7 and 3, so there's no pairs. So this radical would stay the same. For the denominator, square root of 49 would be 7, and the square root of x squared, again, you can write both x's down if you want. There's a single pair of x's, so the square root of x squared would be x. And your final answer would be radical 21x divided by 7x. And again, the numerator is in the radical, the denominator is not, so you cannot simplify the 21 and 7 or the x's. Title of the first section of notes today is Adding Radicals. First problem is 2 radical 5 plus 4 radical 5. When adding radicals, the radical number underneath the square root must be exactly the same. As long as they're the same, we can add the coefficients. 2 plus 4 would be 6, and the radical 5s would stay the same, so our answer would be 6 radical 5. Second question, and last question for the section. Radical 18 plus radical 2. This time the numbers underneath the square root or radical are different, so what we have to do is change one or both of them. In this case, the 18 we can do a factor tree for. Two numbers that multiply get 18. Could use 9 and 2. The 9 we can factor to 3 and 3. Circling our pairs, we have a pair of 3's. That number would go outside the radical, and we have a single 2 that stays inside the radical. Bringing down the plus radical 2. Our new problem would be 3 radical 2 plus radical 2. There's no number in front of the radical. We can put a 1 for the coefficient. Both radicals are exactly the same, so we can add the coefficients 3 plus 1, and the radical 2's would stay the same. So our final answer, 18 radical 18 plus radical 2 would be 4 radical 2. Next section of notes is titled Subtracting Radicals. First problem is 6 radical 7 minus 4 radical 7. Just like when adding radicals, when we subtract, the number underneath the square root or radical must be exactly the same, and then we can subtract the coefficients. In this case, it would be 6 minus 4, which would be 2, and the radical 7 would remain the same. So our final answer would be 2 radical 7. Second question is 2 radical 12 minus 7 radical 3. Again, before we subtract radicals, the radical number must be exactly the same. In this case, we have a 12 and a 3. So you want to factor whichever one we can. The 12, for example, we can factor that to 4 times 3, and the 4 we can factor to 2 times 2. So radical 12, we'd have a pair of 2's, and the 3 left over would go on the inside. It would be 2 radical 3. The question is 2 radical 12, so this extra 2 would come down, and we can multiply by the pair of 2's that we had. So this would be 4 radical 3. And we're subtracting 7 radical 3. Again, once the radicals are exactly the same, you can subtract the coefficients. 4 minus 7 would be negative 3, and the radical 3's would stay the same. So our final answer would be negative 3 radical 3. And last question for the section is negative 5 radical 3 minus 3 radical 3. Again, the radicals in this case are exactly the same, radical 3. So we can subtract the coefficients, which would be negative 5 minus 3. Same signs, we would add those, becomes negative 8, and the radical 3 would stay the same. So our final answer would be negative 8 radical 3. Last section of notes today is titled Multiplying Radicals. First problem is radical 2, and the quantity, or inside parentheses, is radical 8 minus 4. When multiplying a radical times a parentheses, the same property that we've done before, we can use distributive property. Multiplying radical 2 times radical 8, since they're both underneath a square root or a radical, we can multiply 2 times 8, which would be 16, and leave that number underneath a radical. And then minus. Multiplying a radical 2 times a number that's not inside the radical, that number 4 would go outside the radical, and the 2 would stay inside the radical. So radical 2 times negative 4 would be negative or minus 4 radical 2. Simplifying this problem, radical 16 or square root 16 would be equal to 4, and radical 2 cannot be simplified. So our final answer would be 4 minus 4 radical 2. The 4's you cannot subtract. One has a radical after it, and one is just a number. In order to subtract them, they both have to have the same radical. Second question is 2 radical 3 multiplied by the quantity, or inside parentheses, radical 3 minus 1. Again, just like before, we will distribute the 2 radical 3 to both the numbers on the inside. 2 radical 3 times radical 3. The 2 would stay the same because it's outside the radical or square root sign. And radical 3 times radical 3, 3 times 3 would be 9, and that would go underneath the radical. and then minus 2 radical 3 times a negative 1 would stay the same, but it would be minus 2 radical 3. Multiplying the negative 1 times 2 gets you the negative 2. Check to see if you can simplify. Radical 9 or square root 9 is equal to 3. And we can multiply 2 times 3, which would be 6. So our final answer would be 6 minus 2 radical 3. And again, these 6 minus 2, you can't subtract those because one has a radical and one does not. Last question for this section. First parentheses is 3 radical 2 plus radical 3. And in the second parentheses, radical 2 minus 5 radical 3. This time we have 2 parentheses. Both of them have 2 terms or 2 radicals. In this case, we'll be multiplying by FOIL. We'll multiply the first terms together, which would be 3 radical 2 times radical 2. The 3 would stay the same, and radical 2 times radical 2 would be radical 4. Multiplying the outside terms for FOIL would be 3 radical 2 times negative 5 radical 3. The numbers outside the radical, 3 and negative 5, we can multiply for negative 15, and radical 2 times radical 3 would be radical 6. Multiplying the inside term, radical 3 times radical 2, that would be positive radical 6. And multiplying the last terms, radical 3 times negative 5 radical 3. Negative 5 would stay the same, and radical 3 times radical 3 would be radical 9. Simplifying, radical 4 or square root of 4 would be 2. These middle terms have the same radical or same square root. We have negative 15 radical 6 plus 1 more radical 6. We can put a 1 as the coefficient. Negative 15 plus 1 would be negative 14. And radical 6 would stay the same. And the last term, negative 5 radical 9. The radical 9 or square root 9 would be 3. So we can change that to multiplying by 3. 3 times 2 would be 6, minus 14 radical 6, and negative 5 times 3 would be negative 15. Last step, combining like terms. We have a 6 and a minus 15. Both are just integers without radicals. So 6 minus 15 would be negative 9, and minus 14 radical 6 would stay the same. So our final answer, negative 9 minus 14 radical 6. And again, the negative 9 and negative 14, we can't subtract those because the 14 has a radical and the 9 does not. Title of the next section is Rationalizing. Denominators. In this section we'll rationalize denominators, which means we'll get rid of the square roots that are in the denominator or bottom of the fraction. First question, and only question for the section, 8 and divided by square root 7 minus square root 3. In this question we have a fraction which contains radicals or square roots in the denominator. To simplify this, we want to get rid of or cancel the square roots or radicals. In order to do that, we can multiply by a second fraction. Multiplying by what's called the conjugate or opposite of the denominator. Radical 7 minus radical 3. Instead of a minus, we can have radical 7 plus radical 3. So flipping the sign in the middle from a negative to a positive, when we multiply, this will cancel out or get rid of the square roots. If we multiply the denominator by radical 7 plus radical 3, we'll multiply the numerator by radical 7 plus radical 3 also. Multiplying again straight across, 8 times the two radicals. This will be like the distributive property. Multiply 8 two times. 8 times radical 7 would be 8 radical 7 plus 8 times radical 3 would be 8 radical 3. For the denominator of the fraction, we have two binomials being multiplied. To multiply these two, we'll use FOIL, multiplying 4 times. The radical 7 will multiply twice, and the radical 3 will multiply twice. Multiplying radical 7 times radical 7. If you multiply two radicals, we can multiply the numbers. 7 times 7 would be 49. So radical 7 times radical 7 is radical 49. Multiplying radical 7 times the outside term, which would be 7 times 3. Radical 7 times radical 3 would be radical 21. And the last part to multiply, negative radical 3, we'll multiply that one twice to complete the FOIL process. Multiplying a negative radical 3, we'll have a minus or negative for the answer. Radical 3 times radical 7, multiplying would be radical 21. And multiplying a negative radical 3 times a positive radical 3, one negative would stay negative, and 3 times 3 will have radical 9 for the denominator. Simplifying from here, the numerator cannot be simplified. We have different radicals, radical 7 and radical 3, so that would stay the same. For the denominator, we have radical 49 or square root 49. Square root of 49 would be 7. The middle two terms, plus radical 21 minus radical 21. These are the same numbers but opposite signs. So a positive radical 21 and a negative radical 21 will cancel out. And we'll be left with minus radical 9. Taking the square root of 9, that would be minus 3. After multiplying again by the conjugate, simplifying, we do not have any more radicals or square roots in the denominator. Having radicals and square roots in the numerator is okay. So the numerator would be 8 radical 7 plus 8 radical 3. And the denominator, 7 minus 3, would be 4. So our final answer, 8 radical 7 plus 8 radical 3, all over 4. Title of the first section today is Graphing a Parabola. First equation is y equals x squared. Anytime we graph a new equation, we can use a t-table for x and y. The best numbers for x to use are -2, -1, 0, 1, and 2. This will give us a few negative numbers, a few positive numbers, and also the point in the middle of the graph. Filling out the t-table, we'll take each number to the second power or each number squared.